everyone, my name is Ria and today I'll be presenting my project, the Resume Screening Tool. Recruitment is a critical but time-intensive process for organizations. Screening resumes manually takes hours, sometimes days, and recruiters often risk overlooking great candidates due to the sheer amount of applications. To solve this, we created the Resume Screening Tool. This project leverages cutting-edge AI, vector databases, and an intuitive web interface to make resume screening faster, smarter, and more scalable. The tool uses a combination of a Jupyter notebook for development and testing and a Streamlit app to provide recruiters with an easy to use interface for practical applications. Our project is structured around two key components that work together to deliver a seamless experience. Jupyter Notebook. This serves as the foundation where we develop and test the core logic of the resume screening tool. And Streamlit app. This transforms the tested logic into a user-friendly web application for recruiters, allowing them to upload resumes, enter queries, and receive detailed insights. Let's start by diving into the Jupyter Notebook. The Jupyter Notebook is where we built and refined the core functionality of the resume screening tool. This environment allowed us to test every part of the tool and ensure it worked flawlessly before implementing it in the Streamlit app. Here are the key functions that the notebook handles. Setting up the APIs. Firstly, we configure and authenticate the necessary APIs. Open AI API. This API enables us to use AI models for generating embeddings and GPT-4 responses. Pinecone. Pinecone is a vector database that allows us to store and query embeddings efficiently. For example, when we are processing a resume, we generate a unique embedding for each section of text and store it in Pinecone. This embedding is what enables us to perform accurate and fast searches later. Once the APIs are set up, the next step is to extract and prepare the text from resumes using PyPDF2. PyPDF2 extracts text from uploaded resumes in PDF format and cleaning and chunking. The extracted text is cleaned, tokenized, and split into smaller sections or chunks, which are typically 800 characters long. Breaking the text into chunks ensures that the AI can process it more efficiently. For example, a resume might have sections like work experience, education, or skills. Each of these sections is treated as a separate chunk, making it easier for the AI to focus on specific areas. The next step is to convert the text chunks into embeddings using OpenAI's text embedding ADA 002 model. These embeddings are mathematical representations that capture the meaning of the text. They make it easy for the AI to compare different sections of resumes with recruiter queries. For example, a text chunk saying proficient in Python and data analysis would be represented as a unique embedding. This embedding reflects the skills and experience described in that text. Storing embeddings in Pinecone. Once the embeddings are generated, we store them in Pinecone along with metadata such as the original text. Pinecone allows us to perform similarity searches on the stored embeddings. This means that when a recruiter asks a question, we can quickly find the most relevant sections of resumes. Testing the After setting up embeddings and Pinecone, we simulate recruiter queries to ensure the tool works as expected. For example, we might test a query like, does this candidate have experience in Python? The notebook retrieves the most relevant embeddings from Pinecone and uses GPT-4 to generate a detailed human response. For example, the output might be saying the query what we inputted and response as the candidate has 2 years of experience in machine learning, including building predictive models and working with TensorFlow. This process ensures the tool is ready to handle real world queries with accuracy. The notebook plays a vital role in the project for several reasons. Development sandbox, it allows us to test each part of the tool from text extraction to AI responses, ensuring everything works perfectly before moving to the Streamlit app. Debugging and iteration, if something does not work as expected, we can isolate the issue and fix it in the notebook without affecting the user facing app. Experimentation, the notebook gives us the flexibility to experiment with different parameters, AI models, and workflows to optimize the tool for better performance. Now, my teammate Swasha will take forward.
Once we had tested and refined the logic in the Jupyter notebook, we moved on to building the Streamlit app. This app transforms all the complex backend functionality into an accessible, user-friendly interface for recruiters. Let me walk you through the key features of the app. The app allows recruiters to upload resumes in PDF format using a simple file uploader. Once a PDF is uploaded, the app extracts the text using a library called PyPDF2 and displays it for the recruiter to overview. This ensures that the data has been captured correctly and is ready for further processing. For example, if a recruiter uploads a resume, the app extracts sections like work experience and skills and displays them clearly so they can verify the accuracy of the extraction. After extracting the text, the app automatically divides into two smaller pieces called chunks, similar to how it works in the notebook. These chunks are sent to OpenAI's API, where embeddings are generated for each one. These embeddings, which represents meaning of the text, are then uploaded to Pinecone, the vector database. For example, a resume with sections like experience with Python or education is split into smaller pieces, and the embeddings for those sections are stored in Pinecone, ready to be matched with recruiter queries. The app provides an input box where recruiters can type specific questions or job requirements, such as does the is this person an expert in machine learning? This is where the interactivity of the tool really shines, as it allows the recruiters to get immediate answers tailored to their needs. Once a recruiter enters a query, here is what happens behind the scenes. The app generates an embedding for the query, similar to how we processed the resume data. It compares the query embedding with the stored embeddings in Pinecone to find the closest matches. This ensures that the app retrieves the most relevant sections of the resume efficiently and accurately. Using the retrieved resume sections, the app calls GPT-4 to generate a detailed response. This response is designed to mimic how a human would summarize and interpret the data. For example, what is the candidate's experience with Python? Then the candidate has 3 years of experience with Python, including developing backend systems and working on data analysis projects. This level of detail helps recruiters quickly understand the candidate's qualifications without manually reading through their entire resume. The app provides a clear and structured output for the recruiter, including the matched text from the resume, an AI generated explanation of why this data is relevant to the query. This makes it easy for the recruiters to make informed decisions at a glance. Let's briefly look at how the Jupyter Notebook and the Streamlit app work together. The notebook is where we built and tested the refined core logic of the tool. This includes embedding generation, pinecone integration, and query handling. Once we validated the logic in the notebook, we implemented it into a Streamlit. The app takes all the backend functionality and wraps it into in a simple web-based interface. In essence, the notebook handles the technical groundwork while the Streamlit app acts as the recruiter-facing layer, making all this complex functionality accessible in just a few clicks. This combination of notebook and app ensures that the tool is both robust and easy to use. Recruiters can now upload resumes, query for specific details, and get AI powered responses all in one seamless workflow. Now, my teammate Mansi will talk about benefits of the tool.
A resume screening tool offers several significant benefits to recruiters, making the hiring process faster, smarter, and more effective. Efficiency. One of the biggest advantages is time savings. The app processes resumes in seconds, eliminating the need for hours of manual screening. This allows recruiters to focus on shortlisting top candidates rather than shifting through piles of applications. Scalability. The tool is built to handle large volumes of resumes without any drop in performance. whether it's 10 resumes or 10,000. The app processes them seamlessly, making it perfect for organization of all sizes. Accuracy. By using embeddings and GPT-4, the tool ensures that no key information is overlooked. It identifies relevant skills and experiences with precision, providing reliable results for every query. User-friendly interface. The Streamlit app makes everything simple and intuitive. Recruiters can upload resumes, type in queries, and get clear, actionable answers, all with just a few clicks. This ease of use reduces the learning curve and ensures quick adoption. Challenges and lessons learned. While building the tool, we encountered and resolved several challenges, each teaching us valuable lessons. Handling token limits. AI models like OpenAI's have limits on how much text they can process at once. We overcame this by breaking resumes into smaller pieces or chunks, ensuring the tool worked efficiently without losing context. Integration across platforms. Combining multiple technologies, OpenAI for embedding, Pinecone for storing and researching data, and Streamlit for the user interface required precise synchronization. Embedding generation, database queries, and user interactions all needed to align perfectly, which was a challenging but rewarding task. Data privacy. Resumes contain sensitive information, so we prioritize data security throughout development. We implemented safeguards to handle resumes responsibly, ensuring that the tool met high standards for privacy and compliance. Future improvements. Our tool is already powerful, but we see many opportunities for further enhancements. Here's what we plan to add in the future. Advanced filters. We aim to introduce filters that allow recruiters to search resumes based on specific criteria, such as certifications, years of experience, or technical skills. This will make searches even more precise. Automated interview scheduling. Imagine a recruiter being able to not only shortlist candidates but also schedule interviews directly through the app. This feature would integrate seamlessly with calendars and save even more time. Handling non-standard resumes. Many resumes contain tables, graphics, or unique layouts that make extraction challenging. We plan to improve our tool's ability to process these complex formats, ensuring accurate data extraction regardless of how the resume is structured. Conclusion. In summary, our resume screening tool bridges the gap between AI innovation and the real world challenges of recruitment. By combining the power of OpenAI for natural language processing, Pinecone for efficient data management, and Streamlit for user friendly interface, we have built a solution that saves time, improves accuracy, and simplifies the hiring process. Thank you for listening, and we are happy to answer any questions you might have.